Hi, everybody. Okay, good. The mic is working. Everything is working. Yes, I have many names. I figured if it's good enough for royalty, it's good enough for me. That is my Twitter, Super SGP. If you are interested in things I have to say, you can follow it. If you're interested in hearing me complain about the subway system of New York City Transit, that's probably about 20% of the content on there, so, you know. Anyway, I'm here today to talk to you about raving through the 90s with SVG and Clojurescript. I'm a little worried now that I oversold this title, so there's going to be some flashy lights and maybe some noises at the end. But mostly, in the meantime, I'm going to talk to you about how I've been using Clojurescript in the service of art and fun and the pursuit of a nostalgic aesthetic, and about Habra, which is my live code framework. So recently, my good friend Ramsey Nasser did a talk called How to Write Lisp at Parties and Get Away with It. Fun fact about this photo, it was actually taken by Tiago, who spoke before. We took it from his Twitter because he was at Ramsey's talk. So that's what I'm going to talk about. So I'm going to tell you about why I make things like this in Dart clubs and at demo parties and all sorts of exciting things like that. And the structure, we're going to talk a little bit about live code so you sort of understand the context in which I'm doing this. Can you guys hear me okay still? The mic's in a weird place. Great. Okay. I'm going to show you some of my sketches, and I'm going to talk about the framework, and then finish it off all with a demo in 30 minutes. So we're going to have art, and then code, and then both of them all together, and it might go a little fast because I always have too many things to say. So live code is essentially performing music, visuals, dance, games with code that's written and evaluated in real time, which is probably a concept that's very familiar to everybody here, unlike other places I've talked about this. Live code practitioners make up a loosely organized global community. There's sort of nodes in the States and in Mexico. In Europe, particularly in the UK, Sheffield is a real hotbed. Also, there's people in Berlin. These are some clips from Live Code NYC, which you cannot see at all, but that's the group I belong to, and everybody's really great. People also code weird things. So Evan Raskob live codes music from 3D printers. Kate Sicchio live codes dancers. She's also a musician who works with me in my band, but she does dancers when she's not hanging out with me. At Algomec Festival recently, somebody live coded robots to dance a maypole. And so historically, there's been a number of people who've taken algorithmic approaches to music, right? John Cage, Steve Reich, Brian Eno, Ligeti, and a lot of computer artists who do generative electronic work, including Lillian Schwartz and Frida Naka. I would say that live coding sits as a subset to that more general algorithmic work. And it encompasses the academic and artistic investigation of tools for working with code in real time. And it covers all sorts of different goals, some of them pedagogical, like we've heard about Sonic Pi. Sam Aaron is particularly interested in teaching kids how to use music and the pedagogical approach of live code. Also, there's just entertainment-focused work. I kind of am not teaching anyone anything. I just want people to get hypnotized and kind of excited. And so the kind of performance I do with my band Codie fits under AlgoRave, which is live coding that takes place in clubs. Sometimes it can be really dancey. Sometimes we're sort of in the chill-out room because we're not dancey enough. Some people played Glastonbury recently, which is very cool. And in their roles, AlgoRave visualists tend to descend from the VJ, which is to say their visuals can be viewed as an accompaniment to the music, versus being sort of more visual first, like work like this, which is from Norman McLaren, which is a sound artist. I tend to find the ways that people sync the music with the visuals are conversely correlated with how often the groups play together. Sometimes you go to a show and you just show up and you're like, yes, just give me the Fourier transforms of the music to stick into this visualization. In other cases, like with our band, because we play together a lot, it's a lot looser. But it's not just about the means or the venues that make live code what it is. I think the really exciting thing about it is that the practice is meant to be immersive and fun and transparent, open, dedicated to making computing comprehensible and ever-changing, in fact, which is why the manifesto of live coding is the draft manifesto. Just like everything else, it can be changed. Programs are instruments that can change themselves, and the idea is to sort of show the whole human instrument together. What this looks like can be very different. Different scenes even have different rules about how live or how blank your screen should be. Some places are like, start with a totally blank screen, and other people are like, I'm just going to uncomment stuff that I have practiced before and then tweak some parameters live. Most people would say all of these are valid ways to do live code, and even blank screens are complicated by the fact that like you can just import stuff. So then like how blank was your screen really to start off with? Altogether, though, in almost all of the variations, live code inverts the expectations about responsibilities between machine and person. Live code performance requires tools that allow for mistakes in place, in performances where some of the best parts come, like when you mess up. And it places the human's face on computation again, right? We are there, computers aren't operating by themselves. It's like the opposite of AI art, where somebody is like, oh my God, this computer made art and nobody touched it, isn't it amazing? No, like there's people there who make computers do things, and that's interesting, and you can focus on maybes and complexities and errors. It's also about creating together with the people that are there, right? Like, it's up to the people on the dance floor to also help the musicians make sense of their creative work. So live code is really about like redefining and expanding computing as a concept, plus like going to a dark bar. So like I don't know what's not to love, really. And much as you would expect from a scene where instruments and definitions of liveness differ, the visualists in the scene can differ pretty widely too. So there's Olivia Jack, who created a tool called Hydra, which is very popular and is used in shows all over. Both Hydra, which is based on video analog synths, and Olivia's work itself make a lot of use of feedback. That's also the case for Shar Stiles, who pairs with a musician called the Set of Arsonist on Ecosystem. They're really interested in creating an ecosystem that feeds back with the music interacting. I'm so sad that you guys can't see all these, they're so dark, but I'll put my slides up somewhere and then you can see them. Then there's Guy John. He's an English visualist. He's the author of 2 visualization tools, ImproVis and Live Code Lab. It's sort of a thing that most visualists in live code eventually make their own tools, at least once. So Guy is really focused on restriction. Basically, his tools can make cubes and spheres, and then he says, well, what do I do to make it not feel like it's just a cube or just a sphere? Ramzi Nasser is also another visualist. He's made Pixels, which is based on the Pico 8 and written in Clojure for the CLR. So he's really focused on creativity through constraint as well. And he likes a simple parsable aesthetic. He says he thinks it gets the audience more involved. Finally, we have the second shout out today to Joseph Wilk, another Lisp-based artist. He's great as REPL Electric. As we heard before, he uses overtone to create his sounds and manipulate visuals. His visuals are really pretty, and I'm a huge fan. So my work, though, which is our next section, tends to be pretty different from a lot of what we've seen going before. I'm really inspired by like the Southern California aesthetics of the 80s and 90s. When I was a kid, that is me in my swimsuit looking like I'm talking probably because I was always talking. And some sweet LA Olympic aesthetics from '84, and that's really a look I like. So I wanted to be able to do work that looks like that. And so, you know, I might make sketches like this with these oversized pixels, or, you know, just a chill swimming pool, something that looks more like a television test screen. I've got some like pop geometry, maybe some 60s TWA poster feels there, and some pop art patterns. I have a big focus on repetition a lot. This is like a very summery looking one. It makes me hot just watching it, so maybe I should switch to the next one for everyone because it's kind of warm in here. So something with geometries, interacting, and blend modes. And yeah, just a lot of big, overwhelming, interacting geometry blend modes. And actually, it can lead to a kind of accumulation that starts making SVGs drop frames, just like a final, overwhelming feeling. And so the system that underlies these works, right, was created around 4 primary goals. I really wanted to work with an aesthetic that was differentiated from that like shader-driven fractal look, not because it's bad, but just because I wanted something different. So I needed a system that supported geometries and patterns in a straightforward way, rather than sort of the pixel concurrencies we saw Lisa talking about earlier. For performances to really engage the audience, I wanted the visuals to be generated from code that's like, even in some partial way, legible to the audience. Even those who aren't necessarily familiar with the language, right? If it's meant to be about making the interaction of the human and the computer comprehensible, the audience needs to see that like my typing and my visuals are linked. Because I had a day job and a performance deadline looming when I started on the Habra, like I literally told my friend I would make visuals for her show and hadn't written a line of the system because I'm smart like that. So I was like, okay, great. How do I do this quickly, but I can keep it growing if I like it? And I thought that was a really interesting computing challenge. We spend so much time talking about the ways that you like plan everything out, and it was nice to be able to do something that I'm like, what if I don't plan anything? What's going to happen? And so because of that, the final goal was to have a resilient system. Performing live means being prepared to have things go wrong. Things will always go wrong, and you want to be able to recover elegantly, but weirdly not imperceptibly, because how would the audience know that you're real if you don't screw up a little bit? So altogether, the system that undertook to meet these needs is La Habra. And I'm going to talk a little bit about how that works. There's going to be a bunch of code on the screen that probably nobody will be able to read, but we shall plunge ahead. So the system is basically a layer cake of JavaScript rendered from Clojurescript through the reagent library. It interacts with the DOM to produce SVGs. It's accessed through an Electron app, and that's all hot reloaded through Figwheel. Another really essential element of the system is using Atom as the text editor. I've written a lot of snippets for Atom that we'll see in a minute. Using the DOM and SVG let me achieve my goal of starting fast and being able to grow easily, because there are like tons of really smart browser engineers writing the graphics engine that I use, and I don't have to write it. So the core of the system are 2 timers and a CX function. One timer redraws the SVG every 50 milliseconds, and the other increments the frame counter every 500 milliseconds. Previously, in other projects, I've used like the modulo of time in JavaScript, but given the event model, that loop is unreliable, and with such big numbers, you can't always rely on hitting the number you need, so a like straight up primitive frame counter was the right thing to do. And then I can use that frame counter to do all sorts of like basic animations. So there's a little animation of lines that eventually, when they get big and fat, look like a sunset from like some t-shirt, you know, maybe put a surfer in front of it. I can also use the frame counter to create rhythms, right? I have a frame helper called nth frame that just checks for the modulo of the frame, and it makes it easy to have pieces that interact. Finally, I use it to cycle through any number of values, right? So I can cycle through scale values and have this sort of primitive animation just by using that frame counter. And you might have noticed I said that it was every 500 milliseconds. 500 milliseconds is an 8th note at 120 BPM, which is a very helpful and useful fact when you're playing with musicians, because then it means I don't have to use OSC or anything complicated or subject to latency to sync with the performers. It's mostly close, and then I use the best computer, which is your brain, to like do the rest of the syncing. It's far more powerful than anything I have like in my laptop. So these timers then dereference a list of decoratable geometries that represent SVG elements. So I have a shape, or a line, or a circle, etc. In each case, that creates a little map that represents the SVG shape. I can decorate it a bunch with style functions, and I can stack them because it's just calling a soch underneath. It's really great. And then draw does the final conversion into the vector that's expected by reagent. So there's a number of reasons that this has worked out really great. The first is that the compositional forms of Clojurescript work really well with the way that visual styles compose. Particular, right, pipelining convenience functions like when and when not, and the sort of function-forward compositions that we saw, right, with our AST earlier. The fact that we can just replace any lambda with its value is really helpful when we're pulling together all of the compositions, and they make it very extendable at performance time. Sometimes I do prepare more complex things like a grid function as a convenience or a shorthand, or I have this whole like generator that took me a little bit longer to write, but in general I'm able to balance, interesting performances with writing things at performance time and sort of moving up and getting better. Another big win with Clojurescript has just been, and SVG together, is in flexibility. SVG in particular allows everything but the most essential attributes of a shape to be defined through inline styles, as well as attributes like on the shape itself. There's actually, I think right now, a CSS proposal to put all of the attributes into a style, into inline styles. And so it's great, because if I forget to do something, like account for the fact I might want stroke someday, I don't have to really go back and change my base generator functions to fix it. SVG just lets me shove all of that into style and keep going. They also have a concept of a group, which is nice. It can take masks and styles, so I can work with collections together. And finally, I can position through both transformation as well as directly. One of the circles here just has its center put in through X and Y. The other one is transformed there, so it's really helpful to be able to grab out of both depending on what I'm doing. And finally, I can render patterns via pattern fills and automatic image repetition. So that dotted circle is actually an SVG of one very small dot that I know that SVG knows how to render over and over again to make a pattern for me. And so this all let me, of course, leverage the DOM, which I was familiar with already. So it's that whole growing together goal. I can, of course, through interop, reach out to JavaScript's math functions without having to build any other convenience functions. And I think that this declarative syntax gives me a whole big win for comprehensibility, for that big goal of I wanted users to kind of know what's going on, right? Like, they can kind of look at this and say, yes, genrect is probably making a rectangle, and it says that it's pink. And it made it really easy for me to show that to people. So if you know a lot about DOM, at this point you might be saying, okay, SVGs are great, but why didn't you use Canvas? It's way more popular with a lot of web artists. It's a lot more performant. It's a lot more stateful is kind of why I did not choose to use it. Right, if you want to set a color and then draw a rectangle with Canvas, you have to set that like on a bigger object. And trying to add just like a big list of pictures, which I'll show you at the end of this, to something, it's really easy to get into a bad state. And I kind of like the idea that SVG is less performant as well. There's something nice about performing breakdown that I think is important to me aesthetically. There's some also like less awesome parts that are stickier, and I'm going to go through these fast because I want to show you guys some pictures. So statefulness and animation are still kind of complicated. Once upon a time, you used to be able to just write declarative animations for SVGs called Smile. It was deprecated in favor of CSS keyframes, which is fine in normal life, but when you're writing live code, you need to like get the keyframes into like a different CSS file, and you don't really want to be doing that, but you want to do an animation live. So you can actually do really gnarly things where you inject rules into style sheets in running code. You should never do that in real life, but you should definitely do it for art. And so I solved it by doing that. And then I had a new problem that gave me a cool new solution, which is that if you add an animation inside my main list of pictures, it's getting re-rendered every 50 milliseconds. I really love this funny effect that it made, but it was not what I was after. Fortunately, Clojurescript has atoms. They work. They're great. It was a pretty simple solution to that statefulness. And now I can have animations that do things like this. Overall, the big downside of that still is that I have to define it in a number of places in 3 spots to get it working. And again, doing that live is a little bit tough. There's also coupling around masks. So this like animated mask image I have to define in 3 or 4 places before it works. And likewise, gradients can be a little tough if they don't line up. You can get this image on the right, which is also kind of a cool mistake. It's an uncommon use case, so the browsers aren't always doing things, to make my life easy. I discovered recently that blend modes work differently on every browser, so I'm actually tied to an old version of Electron that implemented blend modes the way I want blend modes to work. Finally, recollection versus typing was a big challenge for me. Right, I want it to be legible, but I also don't want to like write maps while I'm typing. And so this is where I relied on Atom, which makes it really easy to define snippets, and then you can write placeholders for all of your arguments. So when you're typing and you're like, what's the order of arguments to this function, you already told yourself. So that's all the words. Now I'm going to show you guys some pictures. Maybe put on some music. A little bit softer so you can still hear me talk, but I will show you how all of this works. Excellent. So this is Business Pastel, who is a friend of mine. Let me turn that down a little bit. And said I could use his music to show you guys stuff. So, oh, now I have to mirror this. All right, so this is basically how we do some live coding. Make this a little narrower so we can see the picture. Find where I started. I left myself a whole bunch of cool notes so I can maybe remember what I wanted to show you guys. This. Okay, so first I'm going to just make us a circle, because it's really important often to start with a circle. If you're playing with someone, you might want them to start their bong at the right time. So we're going to do a circle. Going to make it blue. And then I have this really nice function called half width that'll just fill that in for me. Same with the height. We're going to put it right in the middle. And we're going to make it, let's say, I always like to make it a radius of 200. And now every fourth frame, we have a circle. And the circle's cool, but maybe it wants a friend. Maybe we should give it a rectangle. And we can syncopate that rectangle. And one thing I do, because I'm lazy, is I still use these half functions and then go back and replace the values to place things. So this is like one way. You can also use view width or view height or kind of anything, any value that SVG understands as a placement value, I could type in there. This just renders pixels. And so let's make them 100 wide and 100 high, and it's going to come every third frame to syncopate it. There's your friend. That looks good. It's a little too wide. Let's make it 0.7. So it's very constructivist now. Excellent. You guys can still see it. So we're going to do an animation. And I told you it was kind of a pain in the butt, but we're going to do it. So there's one little shorthand I have. So the animation needs an atom. So we're going to say we're going to make an atom. I like to call it move me, so I know what's going to happen. And let's make this a shape. And I have a short shape, which just gives me some of the things I want. Make it a heptagon. And now for the color, let's throw in one of those patterns I talked about. So we have our pattern, and we need to get the ID from the little definition. It'll be called white dots. And then we need to animate it. And I already wrote something called whoosh, so you didn't have to watch me write that. And it'll go every 6 seconds and be infinite. We've defined it. Let's come down here and add our friend. His name's Move Me. And let's hope that that actually worked and you don't have to watch me debug things. Excellent. It's a little hard to see our friend there because everything is white, so maybe we want to make another one, and maybe we want to sort of change the animation function. So I wrote another one called Whoosh 2 already when I was practicing, and I didn't delete it. I'm sorry. So we'll just change it a little bit. But essentially, this is how we're adding those frames. These are all the keyframe numbers, and this is what happens every keyframe. So we'll change that there, and we'll come down to Move Me. Let's copy it. Put it here, make it number 2. And instead of doing all this, we're going to make it, what color do I want to make it? Pink. And we can add a blend mode just using the style thing that we've got. So SVG has something called mixed blend modes. And I can say we're going to do difference. It's ready for us. Come back down here. Do move me 2. But of course, it's over everything. They're a little bit better when they're behind stuff. So because this is just a list that I'm dereferencing at the end, we can move them up here. And I think it'll be better with move me to behind move me. So let's see how that turns out. There we go. They're having a good time. Then we can do all sorts of things. We can add some little freakouts, which is one of my favorite functions. I can say, let's say every 6 frames, we're going to make a bunch of circles appear. We'll make them a radius of 20. We'll make 100 of them. Oh, not 1,000. That's a lot. Right. We'll make it orange. Now it's going to get even more festive. There we go. So when you write your convenience functions, and it's like, oh, that works out great. And then now I just kind of wanted to get bananas, so I saved myself a bunch of things to uncomment and show you guys so you can see how everything starts going. Got different blend modes going on there. Add some more rectangles to overlap and have a good time. But you know, the late 80s, the early 90s, people were really into grids then. I don't know if you know about that, but like Super Lisa Frankie, you know, you've got your vaporwave grids, so we've added those in. Told you it's fun to really start breaking things. Oh yeah, we have that circle that gets bigger. We can add that in.
Check this out.
Shape. Oh, there's one more thing we can do for the ultimate in chaos, and we've got 2 full minutes left. So, I was talking before about how I really like a certain way of using blend modes that doesn't work. I can actually change the blend mode of the whole SVG. So if you're playing with people and you're like, oh, things are about to get really crazy, we can swap it out, and now we have like 2 whole palettes that everything is operating under all the time. Want to get really bananas, do luminosity, and then it's just like black and white sometimes to screw with people. Let's see, we might have one more little thing we can add. They still work. And that's sort of how you live code something in just under 10 minutes. Thank you. Have a good day, everyone.